Number 13 here in 6.3, they've given you this graph over here, kind of looks like an eye, and they did something incredibly stupid. They called this region R, and I did it, I think, because of the word region here. There it is. But the R gets really confusing because we're going to be talking radii here with solids of revolution, so we're going to be using R. So I really wish they had called this something different. I don't know, let's just call that P, okay? So there it is. We fixed the problem. So we're talking about region P right there, and 13 is asking you, multiple choice here, which of these four integrands, again, not the whole thing, just the integrand right here, would be used to compute the volume obtained by rotating region, nope, not R, P, about the line y equals -2. So this then, -2, is your axis of revolution, and this thing is now spinning in that direction. All right, guys, we've got a horizontal axis of revolution, which means this would be a dx problem right here. Always, 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 that'll be the case. The first thing you guys need to determine, or I guess the second thing, after you've determined that it's dx rather than dy, are our cross sections here going to be circles, or sometimes we use the phrase discs for that, or are they going to be washers? So what would I always tell you guys to do? You've got your region P here, which again is kind of this eye-shaped thing right here, and we're going to draw the 180-degree reflection of that region over your axis of revolution. So I would just guess here, this doesn't have to be perfect, that this, that looks terrible, but okay, is going to look something like that. And I would try to give this figure some depth now by doing this. Okay, it's going to look like that on one side, and that's going to be there, and this one would probably be a dotted line. Okay. The important thing is this, though, guys. There is a whole bunch of a gap right here in between the original two-dimensional region and the axis of revolution. And when there's a gap in between, that means there's going to be a hole when we spin this thing. This region is going to kind of look like a donut. Now that I think about it right here, this is definitely going to be a washer problem, okay? And probably the best way that I could draw that, let me get rid of that green that I drew, is that we'd be slicing this region kind of looking here like that, okay? And there'd be a dotted line on the back of it, but there's also going to be a hole right there in the middle of that region. Okay, so our cross sections are going to be washers. So here we go, guys. The area of a washer, all right, we had this in our notes, is going to be pi times the quantity big R squared minus little r squared. And what are big R and little r? Let's draw those, and I usually like to do this in green. Always start at your axis of revolution, which is right here. Big R goes up to the original curve, not the inner part, but the outer part, the higher one right there. So what I just drew in that dark green is big R. And big R here, because it's vertical, would be top curve minus bottom curve. So what stops big R on the top? This function right here, which is y equals f of x. Okay, that's what stops big R on the top, minus, now what stops big R on the bottom? Right here, and that is the line y equals -2. So this is f of x minus -2. That's going to become a +2 for big R. Let me shift colors on you. I'm going to go purple now just to hopefully make this a little bit easier to see. We got to find little r. So for little r, once again, we start at the axis of revolution and we go up until we hit the first curve now and stop right there. So that in purple is little r. And what stops little r on top? This curve right here, guys, which is g of x. So this is going to be g of x minus, again, it's got the same bottom border that big R did, minus -2. So again, that's going to become +2. So putting it all together now, guys, a as a function of x, I'm following this format right here, is going to be pi. And then in brackets now, big R gets replaced by f of x plus 2. So there's big R, square it, minus, and little r gets replaced now by g of x plus 2. Close it, square it, and let's close that bracket. And that's the formula here for a of x, and that would be your integrand if we were trying to find the volume. So hopefully, One of these things, okay, now they should have put the pi there as well, but they were taking advantage of the idea that for volume, they would pull the pi out in front, then start the integral, and it would be everything that's left over. I kind of disagree with what they said here, but I can tell what they mean. So it looks like f of x plus 2 quantity squared minus g of x plus 2 quantity squared. Looks like our answer here for 13 is going to be choice number 2 on section 6.3. Problem number 13.